All right, so this activity, activity 3, position, velocity, and speed, is basically just understanding the definitions of each of these. And we're going to consider this multi-picture figure. So basically, this is half a second of a basketball being thrown up into the air. And there's a fixed amount of time between each of these pictures. So the amount of time, say, from this picture to this picture is the same as from this picture to this picture. So there's just some fixed amount of time, and the whole thing happens over half a second. Just very quick pictures in between them. And now what we're going to do is we're going to start by asking, what is the position vector, which is defined from the origin to the position of an object, and what is that for the initial position. So just defining the position vector by using this example of the initial position of the basketball is right here, so the initial position vector is this right here, and we call that r, that's the position, it's a vector, and we'll put a little I right there to say that's the initial position vector. Now I'll use a different color for the final position, so we also want to look at the final position of the ball, and that final position vector is just from the origin to that final position of the basketball, so right there in the middle of the basketball, and this is just position vector final. And then our third definition that we'll think about is the displacement, which is a vector which is delta r, so the change in r from the initial to the final position. And whenever you see a delta, this change in r, it's going to be the final minus the initial. So the change in position is the final position minus the initial position. And we want to draw the overall displacement vector between the two positions that we've already drawn. So that is just going from the initial to the final position, and this is delta r. Next, we're going to think about the definition of the average velocity. And the definition of average velocity is just the displacement vector divided by the amount of time that goes by. So for the basketball, we just drew what our displacement vector was. And if we want to actually calculate what that displacement vector is, we'll have to use this r final minus r initial. And here you're given what this initial and final positions are. So we can write our delta r, because we'll be using this in our finding our average velocity. So let's just figure out what it is. It's going to be r final minus r initial, which is equal to the final is 127 centimeters, 23 centimeters, minus the vector 12 centimeters, comma 15 centimeters. And if you just subtract from 127, 12, you should have 115 centimeters. And then 23 minus 15, that's 8 centimeters. And so this is your displacement vector worked out. And if we now are going to calculate the average velocity, that is the displacement vector over the change in time. The change in time, we're told, is half a second. So this is just going to equal 115 centimeters, comma 8 centimeters, like we just calculated, over half a second, and that is equal to 230, comma 16 centimeters per second. And that's your average velocity. Now, average speed is a little different because it's not a vector. So, right, our average velocity was a vector that we got by looking at our displacement vector, right? Basically, where did it start, where did it end, look at the difference as a vector, and then divide by the amount of time. And that gives you, essentially, just looking at those two endpoints, what's that general direction we went about how fast, right? So this is our average velocity vector we got from that. But if we want to actually know what the average speed is, what we do is we want to look at the entire path that the ball went. So the entire path that the ball traveled was all up all around here. And the average speed is then that entire distance divided by the amount of time, right? So it's the total distance traveled divided by the total time. And I'll just write that out for us. So average speed is equal to the total distance over the time. And we're told that the total distance traveled right here is 238. So this is 238 centimeters over half a second. And that is equal to 476 centimeters per second. So the average speed is different than our average velocity because it is a scalar. It's a different number. Means something a little different. So the last thing that we have is the bonus here, looking at the instantaneous velocity. And this is just the velocity at any given moment in that picture. So if you just look at the picture, the instantaneous velocity, say, for, and I'll do this in green, for, say, the ball right here is going to be in the direction that it's moving. And since the ball is further apart from one picture to the next, we know it's moving faster. So instantaneous velocity would look like that there. Up here, the ball is moving more slowly. You can tell because that from one picture to the next, it didn't move so far. So it's just like a little instantaneous velocity vector there. And then when we get back, down here, we have our instantaneous velocity vector again is in the direction of the motion of the ball, and it is bigger right there. So I hope that helped clarify the definitions of position, average velocity, and average speed.